Hey Stats class, I want to talk about how to use a spreadsheet to help us with a confidence interval about a standard deviation. So the first thing I see here is I got a data set, so I'm going to go ahead and copy it and then paste it into the spreadsheet. Right? I don't need all those decimal places. These are all whole numbers, so I'm just going to bump this down. All right, now to do a confidence interval about a standard deviation, I do need the standard deviation. So remember, S is a standard deviation. That's a symbol. So I'm going to write STDEV, standard deviation, of my sample. Get that number. So I'm going to need that number. All right, now this is 99% confidence. So I'm going to put confidence is 99%. So as a decimal, that's 0.99. And then I'm going to do alpha over 2. So alpha over 2 is the area outside of the center of this distribution. So again, chi-squared is right skewed. So this is 99%. That means this is 0.99 right here. So each one of these tails has an area of half of that 99% taken away from 100%. So 99 taken away from 100 is 1%. Half of that, half of 1%, 0.005, is above the 0.99, and half of it is below. So that's the number that we're doing here. It's just 1 minus the confidence divided by 2. So I'm going to do equals, got to put a parentheses here because we're subtracting first. 1 minus the confidence divided by 2. So there's my alpha over 2. Okay. All right, now I'm going to do two different calculations here. One is chi-squared lower or left, and the other one is chi-squared upper or right. So to do these calculations, I'm going to do equals. I'm going to start typing chi, C-H-I. And then the two I want is chi-squared.inv. And then the other one is going to be chi-squared.inv.rt for right. So chi-squared.inv, click that. It wants to know what is the probability, what's the area. That's the alpha over 2. So I'm going to do that, comma. Degrees of freedom, it's 1 less than my sample size. So you can see over here I started at 1. It goes down to 12. So that means my sample size is 11. My sample size is 12. My degrees of freedom then is 11. All right, so there is the lower chi-square. The upper chi-square, same thing. I'm going to do equals chi.inv.rt. Right, probability is still the alpha over 2. My degrees of freedom is still 11. So there's my lower, there's my upper. Now this is not these two numbers. All right, so you're not there until you get the actual lower and upper number for the confidence interval. That's what I'm doing here, lower and upper. I'm labeling those. The lower number is equal to, it's always the square root your degrees of freedom. So again, that's the 11 that we just put in. 11 times S. That's why we do S, this calculation. S squared, shift 6 squared. And then you divide by each of these numbers. The first one for the lower, you're actually going to divide by the R, the bigger number. Enter. All right, and now the upper one, you're going to do the same thing. So I'm just going to grab this. Control C, copy, enter, and go up to the formula bar, paste it. But instead of dividing by B5, I'm actually going to divide by B4, the chi-squared lower now, and close that off. And you can see now that is lower than this. So this is the first number, this is the second number. One decimal place, this would be 3 and 9.7. 3 for the low number, 9.7 for the upper number. So that's how we can get a confidence interval for a standard deviation from a data set. All right, does it describe the standard deviation for all times during the week? If you look, it says it was obtained at 3:30 p.m. on a weekday. So it's not, no, it's not all times during the week. It's just those afternoon times. So data and interpretations of, this is called statistical inference. When we're trying to extend what we found out to the population, it's really restricted to the population of what you obtained your data from. So if you didn't sample every single day at all different times, you can't say that, you can't infer that this applies to all days at all times.